Test 1, 2, 3 test. Test 1, 2, 3 test. Hi guys, welcome to this live stream. We're going to be doing a live run-through of using Bolt, a visual scripting tool available from the Asset Store. It's currently available part of our Plus and Pro promotion that we have going for the month of March, and is available free if you buy a Plus subscription. So let's jump into the editor and have a look at it straight away. So the cool thing with Bolt is that it's a graph view, visual scripting available for free when you buy Plus and Pro. We're going to be looking into using it and adding stuff to our game. So at the moment I have this game, but we have no movement, so I'm going to add movement and shooting while we're on the live stream. So let's get started with the setup wizard. So if I was to start a project with Bolt and I hadn't done anything beforehand, I would end up with this Bolt setup wizard available. It will let me run through. I can choose naming schemes, so I can choose if I want to have a human naming scheme or from a programmer from before. I can take the programming naming schemes. So this will make it so that you can find stuff in the search using rigidbody.addForce and stuff like that. So I'm going to use human naming for now. It will also generate documentation if you need to, and generate inspectors and assemblies. So the assemblies are stuff like the specific runtimes of stuff like tile maps and UI. So if you wanna, you can add those to your graph view. And then you also have types. So types are like variables, and you can have custom types available too. So if you were to create a script and then add it as a type, you can do that as well. So I've already done this beforehand, so I'm not going to generate them again. So just to save us a bit of time. So let's have a look at one of the scripts that have already been created within this project. If I go to my macros folder over here in my project view, I can have a look at one of them. So I'll look at the mover one. Now, if I click this button called Edit Graph, it'll open up the graph and the graph inspector. Now I'm going to dock the graph inspector at the bottom, and I'm going to dock the graph onto the game view so you can see it in a big view. Now, the graph inspector is used to tell us what each object, each node within our graph tells us what it does. So for instance, when I click on the start, it tells me that it's called the first time a machine is enabled before any update method. And it will explain lots of valuable information to us by just clicking on it. Now, another thing we need open is our variables window. So if I go to tools and then go to Bolt, if I go to window and then variables, it'll open up this variables window. And I'm going to dock that down the bottom as well, because we're going to need that in a bit. So now that we have sort of the layout for what we're going to create, I'm going to show you what we're actually going to create from a script. So this script was done beforehand. It's our space movement script and shooting script. And if you're not a programmer, it will probably be looking quite intimidating to you at the moment. So let's actually make this using the visual scripting of Bolt and make it so it's a lot simpler to understand. So what I'm first going to do is I'm going to go to my player, and I have no scripts on here at the moment or any visual scripting, and I'm going to add a component. So in the add component section, we have the menu called Bolt, and I can choose between flow machine, state machine, and variables. So a flow machine is the logic, so it tells us like if we press a button to do this sort of thing, and a state machine is obviously a state machine, so it checks for a state and does stuff dependent on that state. We're going to use a flow machine. Now you'll notice that when I added the flow machine, it also added the variables. This is because we have object variables available just for this object in particular. And it also has automatically added in the Unity default functions like start and update. So this allows us to get straight into the programming. Now the first thing I'm going to program is I'm going to program the speed of moving around. So I want to use my horizontal and vertical axes available for the input manager, and I'm going to have them apply a force, I'm going to have them adjust the velocity of the object. Now I don't want to do the physics movements on an update, I want to do them on a fixed update, so I'm going to get rid of this start and update functions. Now I'm going to add my fixed update function by right clicking and then going to events, and then I'm going to lifecycle, and then I'm going to go to fixed update. Now, as we can see here, the fixed update is telling us that it's called every fixed frame rate frame. So that means we won't be going faster if we have a faster frame rate. Now, the next thing I'm going to do is I'm going to add a variable. Now, there are tons of different variables we can have with Bolt. So the first one, as you can see down the bottom here, is the graph variable. Now, graph variables are local just to the graph. So that means that no other object, none of the other graphs on the object can access that variable. Now, an object variable is usable by all the graphs on that object. A scene variable is stored into our scene variables over here and can be used by any object within the scene. The application variables is usable by any graph within the application altogether. And then you have save variables as well, which are the same as the application variables, but they are saved to the player preferences after you finish playing the game. So when you quit, it'll save those to storage for you. Now, for this object, I'm going to be using object variables. And my first object variable is going to be speed. So I'm going to type in speed, and then I'm going to press enter, and it'll add this variable for me. And you'll notice that I also added it to my inspector over here, because we're adding it to the object. Now, the type depends on what we want. So we want to be adding a floating point number to our variable, just to make it go a bit faster. So we're going to have a float. And I'm going to set my default value to be 5, just so that we have some sort of starting point. Now I can always go back and change this afterwards if I wanted to. Now to add this variable to my graph, I go and right click and I add a unit, and then I go to variables and I go to object and then get speed. Now get speed returns the amount that we have set up in our object variable here. Now the other things I need are my inputs. So I'm going to go and right click and add a unit, and I'm going to search input. So as you can see, I can search or I can just click through. And I'm going to input, and I want to get my axis and an axis name. Now I need 2 of these because I want horizontal and vertical. So I'm going to duplicate it and then drag it down. And I'm going to type in horizontal, and I'm going to type in vertical as well. So those are our axes already set up. Now, if you're wondering if this is just a magic word or anything, you can actually find these axes already created in a default Unity project by going to Edit, Project Settings, and Input. And then on the side here, you'll have your horizontal, vertical, and all your different axes that you can use to do the get axis function. Now, we don't need to worry about it too much at the moment. We'll just use the horizontal and verticals. So the next thing we are going to do is we are going to store both of these into a vector free. So we want to go add unit, and then we want to either search vector free or go through and find it. So vector free, and then we want to create a vector free of x, y, and z. So the horizontal will be our x-axis, but the vertical, is it going to be our y-axis or our z-axis? Let's work that out now. So if we go to the scene view, we'll notice that the y-axis is actually going to move our ship up and down rather than forwards. So if we're in the game view, you'll notice that it doesn't actually change the position of the ship. So our z-axis changes the forwards and back, so we're going to have to set that as our actual forward axis. So in our flow graph, we'll set the vertical to go towards our z. Now you may be wondering, why are these objects, these nodes, all dimmed? Well, that's because we're not currently connecting them to our logic. But if we don't want them to be dimmed, we can easily just click at the top here, dim, and it will just get rid of the dimming. But at the moment, I like to see what I'm actually having the logic go towards, so I'll have the dim on. Now the next thing I need to do is I need to multiply the variable of speed by our vector free. And the way I can do this is I can drag out from the variable and drop, and I want to do multiply. And then I'll drag it in the second one. And there we have it. We have a times b, so we'll have our vector free times our speed, and then we need to add this to our velocity. So the final one we need to do is we need to right click, add unit, and then we'll go to player because we already have a rigid body on our player. And then we go to rigid body, and then we want to look for set velocity. So z velocity is here, and then we can drag the new vector free that we have into our velocity, and there we have it. The final thing we need to do is we need to set the fixed update and drag that logic to our set velocity. And now when we have that input, it will go through and check for the input. So let's see this actually playing. So I'll have my whole graph available. And this is one of the cool things about Bolt, is that we can edit it while we're playing. So I can go and press play and you'll see the logic going through. And then we have audio as well. But the movement doesn't seem to be working because I set the wrong multiply. So we need to go back and change this multiply. We'll right click and we'll search multiply. And we want this generic multiply. So we'll do the vector free times the speed and then put it into the transform. Now let's check if it works. And if we, so there we go, we can move around, but at the moment we can't shoot back. And if we go too far to the side, if we go back too far to the side, we'll actually go off the map and disappear. This is because we currently got the boundary set up, but we haven't actually set them up within the actual player controller. So if you have any questions about anything like this, feel free to ask them into the chat and I'll be willing to answer them. With the axis choice, does have a local world option, Gabriel Williams asks. I'm not entirely sure. I think for the axis, do you mean the axis as in the input, or do you mean the axis as in the axis on the object itself? Because in the input, this is our input axis, so it will be like between 1 and 0 and -1. But yeah, anyway, so we have our start section set up with our movement, and I'm going to do something cool. So right now, if someone was to come into our script, they wouldn't understand what was going on with this. Like, they would sort of understand that there was some vectors going on, but I'm going to add a box around it to make it so that we can actually tell our new people what is actually happening. So if I click and hold Control, I can create a group around these objects. Now I can name the group, and I'm going to name this move. And then I can add a comment as well. So I can say, let's put the comment as moves the ship around using the horizontal and vertical axes. Okay, cool. And the next thing we're going to do is we're going to do boundary. So as you may have noticed, when I was moving my player around, he went off the edge and he just stopped and just disappeared. That's because we have a boundary set up already with a destroy by boundary, but we haven't made sure that our player can't go into that boundary. So let's actually do that now. The first thing we need to do is we need to create a rect variable. So a rect is basically a 2D rectangle that we can have a min and a max for. So I'm going to create my rect by calling it boundary, and then I'm going to set the type to be rect. And there we have it. We have our rect. Now I've already got some values set up, so I'm going to do -4 on the, -6 on the x, sorry, -4 on the y, and then 12 on the width and 12 on the height. The next thing I'm going to do is I need to get my rigid body's position to make sure I can check if he's going off the edge. So I'll right click, I'll go player, and then rigid body, and then I'll get my position. So get position. Now the next thing I need to do is I need to get my get the rect so I can access those values that I put in. So I'm going to create my variable by going add unit, and then go to variables, and then object, and then get boundary, and then I'm going to make it so I can actually see everything in this rect. So I'll drag it out and I'll search for rect, and then go into the rect menu and do expose rect. Now it's not static, so I'm going to get rid of that so we don't have that extra one at the bottom. And the key ones we're going to look at are the x min, the y min, the x max, and the y max. So the next thing we need to do is we need to expose the position here, the vector free. So we can drag it out and we can go to vector free, expose vector free. Now again, it's not static, so we'll get rid of all the static functions. And then we have our x, y, z, and we have our x min and our x max and our y min and our y max. The next thing we need to do is we need to clamp it. So clamping means that we won't go below or above the values that we have set. So I can create a clamp node by right clicking, add unit, and then searching clamp. And there we have mathf clamp, and with a value of min and max. So we'll start with the x, so we'll do the x is the value, and then the min is the x min, and the max is the x max. Now again, I'll add the same unit again by going to math, and then going to clamp, and then we'll have the Z, because the Y isn't actually our movement forwards, the Z is, and then we'll have the Y min as the Y min and Y max as the max. Now we need to put this into a new vector free to put it back into our position. So we'll right click, add a unit, and we'll search vector, and then we have vector free, and then we'll create a new vector free like we did before and put the values as X and the value as Z. Now the final thing we need to do is we need to set the position. So we've gotten the position before, so we'll set it the same way. So we'll add a unit, player, rigid body, and then set position. Now we can just drag the position into it. And the final thing we need to do is attach the logic. So we'll attach the logic from the last one to the new one. I'll just move this a bit more down so we have a bit, you can see the line. And then if I was to press play now, it should hopefully move us to the edge of the screen, but not allow us to go off the screen. So there we have it. We can't move off the screen. We can't move too far down. We can't move too far up. We have this 12 by 12 box. And obviously I can't shoot back yet, so we still need to add that. So yeah, it's a pretty quick way of adding our boundaries to our game. So the final thing we need to do on our movement thing is to add in our tilt. So at the moment when we're moving back and forth, it doesn't really look very snazzy. It looks very boring. We're not really adding much sort of motion to our vehicle. It's just sort of floating everywhere. And we kind of want to add some more sort of movement to our ship. So, but actually before that I need to do the same grouping as I did before. So I'll grab the group and go over it, and then we have the group set up, and we'll set this one as boundary. And as before, I can always set my comment. So I'll set the comment as stops the player moving off the screen. So this is really useful for helping people understand what you're doing with each part of your script. And I really love this tool within Bolt. It's really intuitive to use and really nice, and sort of helps with the user interface. So I'm going to change some colors around as well, which is pretty cool. So I'll grab both of them and I'm going to make one red and one orange. There we go. Okay, and the last thing we're going to do is that tilt. So as before, I need to create a new variable. So this variable, I'm just going to call it tilt angle. And I'm going to add it into my variable list, and I'm going to set the type to be a float again, and I'm going to set the angle to be -30 because I want to turn it 30 degrees away from the direction, towards the direction it's going, so it will sort of tilt towards. So it will look like this. If I was to rotate it on the Z, it will sort of tilt if we're going left, and then I can move my person left like that, and then come back in and go right the same sort of direction but opposite. So let's get started with that. So we have our tilt variable. Let's add that into our graph. So as before, as I've been doing with each variable, I'll right click, add a unit, and then go to variables, object, and then finally get tilt angle. I'll also need to check if my velocity is moving on the horizontal axis. So our horizontal axis is X, because we're moving left and right on the X axis. So we'll go add unit, player, rigid body, and then we want to get velocity. But we don't want velocity on everything, we just want it on the X. So we'll drag that out, and then we'll go to the vector free, and then we just want to get the X. So there we have it, we have just the X available for us. Now we're going to multiply these two values together so that we have the value going in the right direction. So we'll drag out the variable and do a multiply. And then we'll drag it in the X and the tilt angle. And then the other thing we need to do is we need to put it into a quaternium. So quaterniums are a big subject. If you want to learn more about quaterniums, I would recommend Googling it. Try not to get yourself too deep into them because they are quite crazy. But we're going to use an Euler angle for our quaternium. But wait, that's the wrong one, sorry. We want to use the Euler XYZ. And then we want to only rotate onto our Z axis. Now finally, we need to apply this rotation. So we'll do right click, add unit, rigid body, and then we want to set the rotation. So we set rotation and then drag in the Euler angle into our rotation. And then finally, as we've been doing with each one, we need to drag the logic to continue. So we'll drag it in, and now we can have a look at it playing. So it should hopefully tilt. Oh, it tilts a bit too far. So what we can actually do is you can pause the game. We can have a look at the object variable and maybe lower it down a bit to like 10. And then it should look a bit better. Cool. So the only problem with the variables is it doesn't save on play, so we'll actually have to reset that again. The only things that do save on play is when you're actually doing the graph editing. So for instance, if I wanted to maybe change it so that this is divide instead of multiply, I could just play the game. And if I was to pause it and then actually edit the script now, so I'll go add a unit and I will do division. So divide, and we'll do the x and the variable, and then we'll add that to our z. So I'll see that the multiplier is now grayed out because we're not using that one anymore. And if I unpause, it doesn't do anything because it's not really setting the right sort of angle because we're dividing. But if I unpause, you'll see it goes back. So we can actually play around with the programming while we're playing. So now I'll set this as a group again. So I'll drag it out. And actually I'll set two groups. So I'll set the first group as this, and then we'll name this tilt. And then the second group, we'll set all of these as being our movement. So if I drag it out, and then movement. Now the cool thing with setting up these groups as well is that if I wanted to move all of these at the same time, I could just grab the group and move it. If I want to just change the boundary position, I can drag that one and move it. So it makes it like sort of keeping your scripts a bit tidier, easier by just like using the whole group system. So the next thing we're going to go on to is the input for shooting. But I'm going to see if there's any questions. Doesn't look like we have any at the moment. But yeah, as Matt has said before, there is the Bolt Asset Store link is available in our description at the moment, so you can have a look at that. So let's move on to using spawning some objects. It's debatable, Andre. You can do it onto the rigid body as well. Like I personally normally do it onto the transform like you do, but I know people that do the rigid body rotation. So let's move on to doing our shooting. So I'm going to do a new sort of section here. I'm not going to use the fixed update. I'm just going to use an event. So the event I'm going to use is I'm going to go and find it out. So events, and I want to do some input, and I will do on button input. So you may have noticed earlier when we checked the input manager, there was an axis called fire1, and I'm going to use that input. So I'm going to do fire1, and I'm going to do the action of hold. So when I hold down the button, it will fire multiple weapons, multiple bullets. So let's first create our bullet and our bullet transform locations. So I need to add in a bullet prefab variable. So that's going to be a game object. And I'm going to add in another game object, which is our bullet transform. Just to the location that our bullet's going to spawn. So I can either set these in the variable window here, or I can set them in on the inspector over here. So I've got a shot spawn already set up, so I'll just drag that one in. Oh, I haven't actually set the variable yet. 1 second. So player, object, let's do bullet, spawn. And then we want to have both of these as game objects. So game object and game object. And there we have it. So shot spawn goes into our bullet spawn. And then I have a prefab already set up for our shot. So we can drag that into our game object for our bullet. Cool, so now I've got those variables set up. The next thing I need to do is to get them into our editor. So I'll add a unit, and I'm going to go to variables, object, and then we're going to get the bullet. The next thing I'm going to do is I'm going to get my position and rotation of my shot spawn, because we need them for when we're instantiating an object. Now, instantiating means it's just a nice word for saying spawn the object at this location with this rotation. So I'm going to right click and I'm going to go to my variables again. I'm going to go to object and I'm going to get my bullet spawn. Now I want to get the bullet spawn's transform as well as the bullet's rotation. So I'm going to search transform and I'm going to get my position and I'm going to get my rotation as well. So I can either search get position or get rotation, and I can search through all the ones that are available. So as you see here, we'll get the ones for rigid bodies as well as the ones for transform. But I just want the transform one because there's no rigid body on my shot spawn. So the next thing I'm going to do is I'm going to create a new node and I'm going to search for the unit called instantiate. Now this is the tricky part of trying to type. Instantiate. Okay, and then we want to instantiate our game object at the with the original, the position, and the rotation. We don't want the parent, we just want the free input one. So we have our original as the bullet. There we go. And then we have our transform as our position. This get transform, position, sorry. And then we have our get rotation as our rotation. Now the final thing we need to do, as we've done before, is drag in the logic to the instantiate. And now when I press play, we should be able to press Control or left mouse button to shoot some objects. But you may notice we're just going crazy now because we don't have any time limits. So I can literally win this game pretty easily. Just keep spamming it. As long as I move in time. Oh. So yeah, maybe we should add in some sort of time limit on the actual bullet. So I'm first going to set up my group again like I've done before. So this will be the spawn of the bullet. And then I'm going to set up my next section. So my next section is going to be to have two new variables. One to check if we can fire. So we want a time sort of to add to the fire rate. So that will be our fire rate. And then the second one will be our our next fire time. So I'm going to do the first one, fire rate. So this will be the interval at which we can fire. So this will need to be a float. And I'm going to set it to be 0.25 seconds. Now the second one is going to be next fire. So this will determine if this will be checked about against time to see if we can fire. So I'll add that one, and that needs to be a float as well. And we don't need a value for this because it will be incremented by using our fire rate. So let's create those in the actual graph. So the first one's going to go over here. We're going to do add a unit, and then we're going to go to our variables, object, and then we want to get next fire. And then the next one we're going to do is we're going to get our time node. So we want to right click, add unit, and then we'll search time. And then we can get the time. So here we go, set time. And then we want to check them against each other. So we want to use a Boolean. So if I right click and search add unit, you'll notice there is a section here called logic. So we want to check if they're greater than. So the first one is going to be our time node, is the A, and then our B is going to be our next fire. Now we want to have some sort of logic come out of this, so we'll use some control and a branch. So this is the same as using, say, an if statement if you're used to programming. And then we'll say if the Boolean that we're checking is if A is greater than B. And then we can also drag that into our branch, into our logic. And then we'll add the, if it's true, we'll spawn an object. Now, at the moment, that won't do much because we're not incrementing our next fire. So the next thing we need to do is to actually increment it ourselves. So we're going to update the fire rate, but first let's actually set our group over here. So it'll be like check time against next fire. And then the final one is over here. So we'll go to variables, go to object, and then we'll get the next fire because we're going to increment our fire rate with that. And then we want to also get the time node, so we're always staying up to time. So I'll search time again, and time, and then get time, and then we want to add these two together. So I'll drag it out, and there should be an add node right here, and then we add the two together, and the result should be set into our next fire. Oh wait, sorry, I've got the wrong node here. So this actually needs to be our fire rate instead of next fire. So luckily, if we're in the object variables, we can actually choose between any of our variables on that object. So I'll change it to fire rate, and then we want to set this onto our next fire. So I'll go add unit, go to variables, object, and then set next fire. And then we want to set the A plus B of this into our next fire. And there we have it. So now we need to add in the logic from our branch. So we'll drag that logic over, and then hopefully we should now see the time increment the variable and being able to shoot every 0.25 of a second. So when I shoot, you see the time increments. So at the moment we have our time at 5.43, and then we're adding 0.25 to it, so our resulting is 5.68, sorry. And then it will check it against, oh, okay, so there's not enough time at the moment, so we need to wait a bit before we actually do make it true again, so we can go through the branch and instantiate an object. So if I hold it down, it won't go crazy like I did before. Now if I wanted to, I can change the object variables, so I'll change the fire rate to like 0.2, let's say 0.1 actually. And then let's play it, and then you'll see I'll shoot faster, and you'll see in the graph, the logic is going through a lot faster, so you'll see lots of like dots going through, and it's very visual for helping you to understand what your script is doing. Cool, now the last thing I'm going to do is to add in some sound effects. So on my player already, there is a sound effects audio source. Now what we're going to do is just literally going to add in audio source and audio source literal, and then we could just, oh sorry, that's the wrong one. Let's go to audio source, and then play. So the one we want to play is the one on ourself, so I can literally just drag that in if I wanted to, and then attach the logic into the spawning and then the setting. So if I press play now, we should be able to shoot and hear a sound playing at the same time. So let's see. There we go, we have our audio playing. So we have a nice little game going now, and if I manage to not die, it will probably go on forever. And I died. But yeah, so this is a great tool. It's available for free if you purchase a Plus subscription anytime within March. So I'd recommend doing it if you're not really into programming and you want to sort of learn about the programming before you actually get into scripting. This is a great way to sort of leapfrog yourself into getting into programming. Now let's see this in comparison to our script. So this is what it looks like in visual scripting. It's a bit easier to understand. You have your section set up, and then we have the script version, which is this, which is a bit more intense than the visual scripting. So if you have any questions, feel free to ask them in chat now. I'm willing to answer them at any point. But we can always add more into this if you wanted to. I'm actually going to just add in a bit more groups here, so I'll drag this one out and do this one as the setting of the time. Set time. Oh, not time. So you may notice there's a couple of tips that we can do. So one tip is that, as you might have noticed, when I double clicked on an object, like a group, I can see that object, like the group in particular, so I'll double click it and it takes you to that object. Now another one we could do is we can press Shift and space and it should make the whole node view full screen, which is pretty cool. And then we can also add in like another one here, so we can just say plays audio source and stuff like that. Powell Dabrowski asks, can you hide unused sockets to make it look more compact? I don't know. I haven't tried it myself. It's best to ask Laszlo, as he's the guy who made it. I think he might be in chat at the moment. We can have a quick look through like the documentation. So yeah, with when you buy this, you actually do get like a whole manual, which is pretty cool. So I'll open it in Chrome and then you can have a quick look. So we have this whole sort of setup where we can find answers to our questions, which is pretty cool. So let's search hide sockets. So unfortunately, it doesn't look like there's anything on hiding sockets. But you can create your own variables, which is pretty cool. So for instance, if I wanted to have an int array, I can do it by creating a script and just setting it so it's an int array, and then we can have like that within our actual visual scripting as well. So there is an opportunity to expand the actual bulk sort of libraries if you wanted to, which is pretty cool. So I'm going to wrap it up. So thanks for watching. Just to remind you that this is available for free if you purchase a Plus or Pro subscription. Feel free to check it out and let us know how you get on with it, and send us anything you want on Twitter. If you make something cool, feel free to let us know, and it'll be awesome to see people using this tool. So thanks for your time, and I hope you enjoyed the stream.